In this video we're continuing our work on surface area, and we're looking at in particular the surface area of cylinders. Have you ever pulled apart an aluminium can? If you have, you'll know that, a bit like in this picture here, you start with the can, and one thing you can do, if you pull it apart or cut it around there, you'll have the top of the can, let's say it's a soft drink can, and the base of the can, and you can unwrap it, and you've got the tube part along the side, and it can, if you're careful, you can unwrap that into a nice flat sheet. So when you've unfolded and pulled it apart, you've actually got 1, 2, 3 parts. These 3 parts are a circle on the top, a circle on the bottom, and a rectangle. Now, a can's not a perfect cylinder, but if we do look at an actual perfect mathematical cylinder, we notice a few things. If we go back to this first diagram here, we've got the height and the radius. Now this is a prism, isn't it? From the previous video you note that a prism is wherever you cut along you'll get the same cross-sectional shape. If this was solid we'd get that same circle all the time, just as a side note. So if we look at this diagram, we've got the two things, the main 2 bits of information, the radius and the height. Sometimes we're given the diameter instead of the radius, which is right across. So with the radius and the height, we can work out the surface area. We have 2 circles if it's a closed cylinder. Be aware that sometimes we have an open cylinder which might be open at the top, and thus we would only have this bottom circle here and we wouldn't have this top circle. Or some are hollow pipes, or the tube only, and you wouldn't have either circle, you just have the tube part. But for this closed cylinder we have the area of a circle, the area of a second circle, that's 2 areas of the circle, 2 circle areas, plus a rectangle, and once we have those added together we have the total surface area of the cylinder. Let's look at that in more detail. So 2 circles and 1 rectangle makes the total surface area of a cylinder. So we have 2 area of a circle is pi r squared. So 2 lots of pi r squared plus 1 rectangle. Now if we think about the rectangle, when we unwound it back in the previous, unwound the tube part back in the previous picture, and if you've forgotten, please wind that back now and look at it, it unwound the distance around the circle. So the amount that the tube part unwound is equal to the distance around the circle, which we call circumference. Remember circumference? C for circumference. So the length of that tube part as we unfold it, once it becomes a rectangle, is the circumference. That distance is the same as the circumference of the circle. Go back and have a look if you need to see that previous picture. And we also have the height. So its area is C times H, because that's the same as the length times the width, except for it's got different symbols. How do we get the circumference of a circle? Recall, it is 2 pi r is the circumference. So the area is, instead of C, we have 2 pi r times h, which you can see there. We can simply remove the multiplication sign, and we have removed that multiplication and that one, and we have 2 pi r squared plus 2 pi r h, circular ends and the curved area. Therefore the total surface area of a cylinder is 2 pi r squared plus 2 pi r h. If you like, it's an option, you can factorize it. They both have a factor of 2 pi r in them, we can take that factor out and you can write it like that. But that's optional, you don't have to use that. It's okay if you stick with that formula. So let's look at some quick examples. So we have a cylinder here and we need to find the surface area. We'll write our formula out first. 2 pi r squared plus 2 pi r h. 2 pi, now the radius is 5, that's times 5 squared, plus 2 pi, again the radius is 5, h, the height is 25. Just because it's laying on its side doesn't mean that it's not the height. So the main axis is the direction that the height goes on. Even if it's lying down on its side, it's still the height. Let's get our calculators now. We'll calculate it a little bit at a time. So 2 times pi times 5 squared is 2 times pi times 25, and 25 times 2 is 50, so that's 50 pi. Five times 25 is 125, times 2 is 250, that's times by pi there. So that's 50 lots of pi plus 250 lots of pi is 300 lots of pi. We can get, if you want a decimal approximation, 300 times pi equals, I get 9,424.78. So 9424.78. 9424.78. And because it's a surface area, we have squared units just like regular area. One final example. This one's a little bit different. We can see that it is a bit like half a cylinder, and really that's largely true. So if we look at the surface area, we do have half a cylinder, but the question needs to be clear about whether we're including this bottom surface or not. So I'm talking about the base of it there. Now if the question does want us to include the base, we probably should draw a net now, because this is a more complicated shape. So if we start with that base and we are including it, we can draw the net down the side. It's a rectangle, and we got 8, we've got 4 across. If we unfolded the tube part out, we'd have to fold it out on one side. Let's fold it out on this side, and it'll go around into another rectangle, and then we have, so that's the tube part. Then we have 2 semicircles which would fold out at each end of the base. Yep. Now if we think about it a little bit more, and thinking's good because it saves us a bit of work, makes us more efficient. The 2 semicircles here, even though my drawing is a bit lousy on this tablet I'm using, if you put them together they equal a full circle. So what we have is equivalent to a full circle plus a rectangle, which is the base, plus a different rectangle, which is the tube part that's been folded out flat. So what can we do? I'll move my writing over a little bit. So the total surface area Alright, so we've got the full circle, that's pi r squared plus length by width. Now this distance here on the previous one, let's put that in green, was that distance was the circumference, but this is half the circumference. So instead of 2 pi r, we have pi r. So that distance there will be pi r, because it's half of a circumference. A full circumference would be 2 pi r. This is only half of that. So that's pi r. And of course we've got the other part of the rectangle as that distance there. You'll notice that it's the same as the 8 centimeters. So we could call that length because we called it length before. Times length. Let's put some numbers in. So it's pi. Now the radius is 2. See that? That's a diameter. So the radius is 2. So 2 squared plus 8 times 4 plus pi times, again, the radius is 2 times the length, which is 8. That's 4 pi plus 32. Let me just correct that too. That looks like a multiplication, but it is a plus. Sorry about that. Plus 16 pi. 4 lots of pi plus 16 lots of pi is 20 lots of pi, plus 32, and we get our calculator if we want a decimal approximation. 20 times pi equals, and then the rest of it was 32 plus 32, 94.83. So we put in 94.83. 94.83 centimeters squared, because it's an area. I've just seen a little mistake. That should be centimeters.